I'll never forget the time I tried making what I thought would be a cozy rustic stew for a dinner party.
Oh, wait.
Yeah, I threw a bunch of expensive beef and vegetables into a pot, covered it in broth, and just let it boil for hours. And the result, I mean, it was tragic.
Sad gray meat.
Exactly, just these tough gray cubes of meat floating in sad, boiling water.
It's a very common tragedy.
Right. But today's mission is about making sure that never happens to you. Because today we are solving culinary struggles using literal calculus. We've got our hands on a fascinating research paper, an absolute deep dive into a quantitative optimization framework for beef stew.
Applying actual physics and reaction kinetics to guarantee a perfect meal.
And what's truly wonderful here is the sheer optimism of this approach. We often think of human ingenuity and, advanced mathematical models as things reserved exclusively for building rockets or solving complex global supply chains.
Right. But we can use that exact same brilliant science to elevate our everyday lives, bringing progress, comfort, and actual joy right into our kitchens.
It really is inspiring. So how do we actually do this? What is the starting point for a mathematically optimized stew?
It starts with an objective function.
Okay.
Essentially, we are mathematically balancing flavor, tenderness, nutrition, and cost to find the ultimate sweet spot. And to hit that high score, the math clearly points to chuck roast as the winner.
Chuck roast, not the fancy cuts.
Nope. It has an ideal ratio of collagen, right around 12 to 14%, and it's highly cost-effective. You want to cut it into uniform cubes exactly 3.5 centimeters thick.
Exactly 3.5. Okay, so I've got my precise cubes. Do I just throw them in the pot?
Not quite. Here's a crucial setup step. You must salt the meat with exactly 1.5% of its total weight, applied 12 hours in advance.
12 hours.
Yes. This maximizes what physicists call Fickian diffusion.
Fickian diffusion. That sounds like a magic spell.
It's just a fancy physics term. It simply means the salt naturally travels from areas of high concentration on the outside of the meat to low concentration on the inside until it's perfectly even.
So we are fundamentally optimizing the meat structure. Speaking of optimization, it actually reminds me of how people use Ember Silk to optimize their professional lives.
Oh, absolutely.
If you need help with AI training, automation, integration, or software development, really uncovering where agents could make the most impact for your business or personal life, you should check out embersilk.com for your AI needs.
It's all about working smarter.
Right. But back in the kitchen, once our meat is thoroughly prepped and salted, we get to my favorite part, the sear. Does the math give us a hard rule for the best sear?
It does. You want roughly 3 minutes per side at around 190 to 210 degrees Celsius. That triggers the Maillard reaction.
Right, that's the chemical reaction that turns brown food into pure savory flavor.
Spot on. Just don't crowd the pan or the temperature plummets, the meat steams, and you lose that browning process entirely. Now, if we look at the next step, there is a massive counterintuitive fact.
Oh, I love these.
Do not fully submerge the meat in your cooking liquid.
Wait, really? Every stew I've ever made says to cover the meat entirely in broth. Why would leaving it exposed be better?
Mathematical modeling shows that half submersion is actually the ideal state. If you fully submerge the beef, convection cools the meat too much. It drops it below 160 degrees Fahrenheit, which stalls collagen hydrolysis.
Meaning it stops breaking down those tough proteins into melt-in-your-mouth gelatin?
Precisely. And to speed that breakdown up, the model suggests adding a splash of acid, like tomato paste or wine.
About a teaspoon per quart, right?
Exactly. That drops the pH to between 4.5 and 5.0. That slightly acidic environment acts like a catalyst, accelerating collagen hydrolysis by nearly 30%.
Mind blown. So we seared it, half submerged it, added a little wine. What's the oven situation?
This is where the Arrhenius model comes in. It's a formula that calculates how temperature affects the speed of chemical reactions. The math dictates setting your oven to 315 degrees Fahrenheit, or 157 degrees Celsius, for exactly 3.5 hours.
Wow, that is precise.
It has to be. You want the lid mostly on, but cracked just a tiny bit, a 5 to 10% vent. This guarantees a perfect 12% liquid reduction, concentrating the flavors without drying out the stew.
Okay, but I have a terrible habit of checking on my food. Is that allowed?
Absolutely not for the first 2 hours.
Uh-oh.
Every time you peak, you drop the internal temperature by up to 30 degrees Fahrenheit, which throws the whole Arrhenius model out of whack.
No peeking. Got it. It really is beautiful when you step back and look at the precision of it all. I just marvel at how science helps us perfect these comforting, age-old traditions. We aren't losing the magic of cooking, we were enhancing it. It completely proves the beautiful, practical progress of human knowledge.
Which leaves you with a fun question to ponder. If we can use the Arrhenius model in physics to elevate a simple bowl of stew, what other intuitive daily rituals could you mathematically optimize today?
I love that. If you enjoy this podcast, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.